Hello, this is Jennifer Martinez, and in this video, we're going to talk about different positions of angles. We're going to start with the standard position. An angle is in standard position if the vertex is at the origin and its initial side lies on the positive x-axis. For example, let's do this example right here where we sketch 75 and 300 degrees in standard position. Let's start with 75 degrees. So I'm going to create a little axis right here. Maybe make it in black. So we know that the x-axis, the positive x-axis, is right there. This is called the y-axis. And the initial side is going to lie on the positive x-axis. So that's where I'm going to start. I'll put the positive x-axis there. And 75 degrees, well, we know that a right angle is 90 degrees. So that y-axis is up 90 degrees. So 75 is a little smaller than that. So that would be this angle right here. I'll draw a little arrow and label that 75 degrees. And we can see here, if we read this again, an angle is in standard position if its vertex, now this is called the vertex, is at the origin and its initial side, which is the initial side is right there, lies on the positive x-axis. So 300 degrees, well, that's going to be in what we call a different quadrant. So if you look here, it says the figure shows ranges of angle measures for each quadrant. When theta, that's the angle, theta, is between, this means 0 and 360. So theta is bigger than 0, but less than 360. So it goes all the way around a full circle. So quadrant 1, Q1 stands for quadrant 1. That is going to be between 0 and 90 degrees. That makes sense because there's that right angle. And then between 90 and 180 is called quadrant 2. And quadrant 3 is between 180 and 270. And then finally, a full 360. So this is positive x-axis can stand for 0 degrees and 360. That is going to be between 270 and 360. And our second angle there is 300. So we know it's in quadrant 4. So let's go ahead and graph that one. Let me get another grid. So somewhere between 270 and 360. So the initial side, let me do it in green. The initial side is still on the positive x-axis, but this terminal side is what we call it, is now going to be in quadrant 4. The angle starts there and goes all the way around. That is the angle 300 degrees. Again, the vertex is at the origin. Now, if your angles land right on the 90 degrees, 180 degrees, 270 degrees, and 360, those are called quadrantal angles. So let's look at that next. Angles in standard position whose terminal side lies on the x-axis or y-axis, such as angles measuring 90, 180, 270, and so on, are quadrantal angles. And that makes sense. Even 0 is a quadrantal angle. 90 degrees is right on that y-axis. 180 degrees is another 90 degrees, so that is right on the x-axis. You add that 90 degrees to that again, that's 270, and 90 degrees again is the 360. It actually goes on. If you add 90 degrees again, you can call that 450. 360 plus 90 is 450. So this angle right here, this 90 degrees, can be considered 90 degrees or 450 degrees, just like the x-axis can be considered 0 degrees or 360 degrees. And that brings us to coterminal angles. Angles with measure, for example, 60 and 420, have the same initial side and the same terminal side, but different amounts of rotation. Such angles are called coterminal. Let's look at that. So first, let's draw 60 degrees. Let me get another graph. Let's put it down here. And first I'm going to graph 60 degrees. So we know 60 degrees is in quadrant 1. It's in the first quadrant. There it is. Again, the initial side is on the positive x-axis, and we go up 60. Now, if we take 60 degrees and add another 360 degrees, you're going to get, 420 degrees. So 420, let's do that in a different color, is going to start again on the x-axis, but it's going to go all the way around 360 plus another 60. It lands on the same place that 60 did. So this could be 60 degrees, or it could be 420, because 60 and 420 are coterminal. Coterminal angles differ by a multiple of 360 degrees, a full rotation. So let's look at the following example. Find the measures of the coterminal angles. We're going to find the angle of least positive measure. So for instance, 908 is not the smallest angle that can be. That is coterminal with each angle. So let me go ahead and get another axis so I can draw that. Let's make that in black. If I take 908 and I subtract 360, what would I get? So we get 8. I'm going to make this a 10, borrow. That would be an 8. So it looks like it would be 548. It's still bigger than 360. So I'm going to do it again. I'm going to subtract 360 again and get 8. That would be an 8. So it looks like 188 degrees. 188. What quadrant is that in? Well, again, the initial side is going to be on the positive x-axis. 180, right? 90 is the first one, the first quadrantal, and the next one is going to be 180. So we know it's a little bigger than 180. 188 is from here to here, 188 degrees. We can see that's in quadrant 3. Quadrant 3. I can erase that 180 and that 90. That was just for reference. It's in quadrant 3. So 908 and 188 are multiples of 360. So the answer for the least positive measure that is coterminal with this angle is going to be 188 degrees. To draw that 908 degrees, it's going to be there, but now we rotated twice. We subtracted 360 twice. So it's still going to start on the initial. I'll do it in a different color, pink. 1 360, 2 360s, and then all the way to there. 2 rotations, and then 188 degrees. It looks quite confusing, but there it is. And you could have been a little more clever than this. If you wanted to, let's bring out a calculator. And we knew that, if you take 360 times 2, you know that it really is going to rotate twice, because subtracting 360, you can see in your head that it's not quite enough. So if you want to just subtract 720, 908 minus 720, use a calculator, you can see you also get 188. So that's the answer. Negative 75 degrees. How are we going to graph that? Negative 75 degrees, we know, goes counterclockwise. So I'm going to start at the initial, in green. And then negative 75, well, we know this is negative 90 degrees going this way. So negative 75 degrees would be in the fourth quadrant. That would be negative 75 degrees. Quadrant 4. To get a coterminal angle for that, you could actually add 360. Again, they want find the least positive. So if we subtracted 360, we just get another negative. So I'm going to add 360. So I'm going to take 360, negative 75, and add it. Just do it on your calculator. Negative 75 plus 360. The negative sign on the TI calculator is down below. You can't do minus for the first number. Now, if you did want to use the minus, you could take 360 minus 75. But the negative and minus are two different things. So if it's in front of a number, make sure it's negative. And if it's one of these, if you're actually doing an operation, then you could use the minus sign. So 285. 285. Oh, 285. Let's just try it here. So this angle right here is 285 degrees as well, with lots of with a normal rotation. And so 285 is the answer. That is the least positive coterminal angle. And what would that look like? Again, it would start on the initial, but now it's positive, so it would go counterclockwise. That would be the 285 degrees. And this does make sense that it's in the fourth quadrant, because if you remember, the negative y-axis here was 270, 90, 180, 270. This was 360. And 285 is between 270 and 360 degrees, as we showed up here. So we did it. We found the angle of least positive measure that is coterminal with the negative 75. So negative 75, 280 are coterminal because they're a multiple of 360. We just added 360 to get it. And it's the least positive measure. I hope that helps.